Today we're going to look at solving radicals and looking at identifying extraneous solutions. So we have something called some special cases where we have an extraneous solution. So this is defined as a solution that does not satisfy the original equation. Okay, when something doesn't satisfy an equation, that means that it won't become a true statement. So that means that we want to be talking about no solution. So you get the answer of no solution when you get extraneous solutions for an answer. So essentially, you're getting false statements where it's something like 2 equals 5. Okay, that's a false statement. So that's why checking your solution is super important, because sometimes you don't get the two to equal each other. So let's dive into some examples here. We're going to solve each radical equation. We'll check our solution. And if there is no solution, we'll write no solution. So if our first equation is the square root of 3x and then plus 8 equals 2. We want to start by moving numbers that are not under the square root. So for us, 8 is not under the square root. I want to get the square root by itself because there's only one square root in this problem. So that means that I'm going to move the 8 by subtracting. That gives us then the square root of 3x. And then 2 minus 8 is going to be negative 6. Now that we've isolated that square root by itself, to get rid of a square root, we are going to square both sides. This is why parentheses are important. Negative 6, that whole thing is being squared. So remember, when you square square root, it leaves you with what was underneath that radical. So for us on the left, it's 3x. When you square negative 6, that's like negative 6 times negative 6, which is positive 36. When we then divide to get that 3 away from the x, we will then get a value of x to be 12. But before I just circle that and go on my way, I am checking my solution. So in this problem, I see an x one time. I'm going to substitute 12 in to that x. So we'll have 3 times 12 under the square root. I want to add 8. And my goal is to have it equal 2. Well, under the square root, 3 times 12 is 36. If I take the square root of 36, we get 6. So if I add 6 and 8, that's going to give me 14. That definitely does not equal 2. And so because it doesn't equal it, that's a false statement. X cannot be 12, which means that we would write that we have no solution. So even though 12 looks like a really nice number, that's why checking your solutions is super important. If we take a look at the next example, notice that we have 2 different square roots. So because there's a square root on each side, I'm going to take the square root of 3x and I'm going to square it. That means what I do to the left side, I'm going to do it to the right side. So I'm going to take that square root of 2x plus 1 and square that as well. That leaves me then with just 3x on the left and 2x plus 1 on the right. My goal is to solve for x. Because it's on both sides, I am going to move one of the x's over. So I'm going to move the 2x over. 3x minus 2x will just give me an x because there's technically a 1 in front, but you don't really have to write the 1. That leaves me then just with the 1 on the other side. So my potential answer is that x equals 1. But I'm not going to say that it's my answer until I've checked it out. So because there are 2 different x's, we'll have to substitute that value of 1 into both and see if the left side equals the right side. So under the square root, we'll have 3 times 1 on the left. On the right side, we'll have 2 times 1 plus 1. Well, under the square root, 3 times 1 is 3. Under the square root, 2 times 1 is 2. If I add 1 onto it, notice that we get the square root of 3 on the left to equal the square root of 3 on the right. That checks out, so that means I am able to circle x equals 1. That is my solution. If we look at the next example, notice that we have negative 2 times the square root of 2x plus 5 equals 6. My goal is, because there's one square root in this problem, get the square root by itself. Because there is a number out in front, I'm going to have to take that negative 2, and because it's technically being multiplied, the opposite would be to divide. When I divide both sides by negative 2, it'll leave you then with the square root of 2x plus 5, and then that's going to equal 6 divided by negative 2 is negative 3. Now that those other numbers, the 2 and the 5 on that side, are under the square root, I can't move them. So with that square root isolated by itself, I'm going to square it to get rid of the square root. And what I do to one side, I'm doing it to the other. So negative 3 in parentheses is getting squared. Squaring that square root on the left just leaves you with what was underneath that radical, so 2x plus 5. Negative 3 quantity squared you think of as negative 3 times negative 3, so positive 9. Now we have a couple of steps to get the x by itself. I'm going to move that 5 first because it's not attached, so the opposite of a positive is a negative. That gives me 2x to equal 4. I'll divide both sides by 2, and my potential answer is that x equals 2. But I can't say it is my final answer until I've checked my solution. So I'm going back to my original problem. My original problem has 1x, so I'll have the negative 2 on the outside under the square root. We'll have 2 times 2 for the x that I think it is. We'll add 5 under there. And I just want to know, is all that going to equal 6? So just focus on simplifying the left side. There's still that negative 2 on the outside. Notice that we have 2 times 2 is 4 plus 5 under the square root. Well, add those numbers under the square root and you get 9. If you put that into the calculator, 2 times the square root of 9, well, the square root of 9 is 3, and negative 2 times 3 is negative 6. But notice that every time I wanted it to equal positive 6. So this is not true. Because those two sides do not equal each other, we are going to have to say that we have no solution, because we didn't have a true statement. If you take a look then at this fourth problem, we have negative square root of x minus 2 equals the square root of 2x plus 7. So once again, we've got square root on either side. So I'm going to take that entire left side and I'm going to square it. On the right side, I'm going to do the same thing. Now remember, when you square something, you're multiplying it by itself. So that negative on the outside and the left, you're taking a negative times a negative. That's going to turn into a positive. Under the square root, we will then have x minus 2 because we were squaring a square root. On the right side, we'll take what's under the square root, which is 2x plus 7. Got to start solving for x. We got x's on both sides. I'm going to move the 1x over to the right by subtracting. That gives you negative 2 to equal x plus 7. Last step to solve for x is I'm going to subtract 7 from both sides. And that gives me a potential answer that x equals negative 9. Notice that in my original problem, we've got several different x's, so I am going to substitute them in. So when I check my work, I'm going to substitute negative 9 in. So in the left, we're going to have that negative sign on the outside, and then under the square root, we will have negative 9 minus 2. That's going to equal, under the square root, we will have 2 times negative 9 plus 7. So under the square root, notice that when I subtract negative 9 and negative 2, we get negative 11. Under the square root on the other side, we'll get negative 18 plus 7. So we'll have that negative and then square root of negative 11. On the right, when I combine those numbers, we'll have a negative 11. But here's the thing, they're not the same because there's a negative out in front of the square root on the left and there isn't on the right. So these are not like, they're not the same. So this is a false statement. So once again, we end up with no solution. So even though we've been practicing quite a few with no solution, doesn't necessarily mean it's always no solution. That's why I threw in this second example here. Sometimes it's going to be like that other video or the lesson beforehand, we did have solutions. So just be very aware of checking your work, making sure that the left side really does equal the right side. Don't lose any negatives. Go ahead and pause the video and try this checkpoint problem. Okay, so hopefully you paused the video. Here is the work. So notice that I had to get that square root because there's only one of them. I had to get it by itself. So that 15 that's outside of the square root, you had to move that over by subtracting. Then, because I have the square root now by itself, I squared both sides. Don't forget that the negative 6, that whole thing got squared. And so a negative times a negative turned that into a positive 36. I wanted to move the two numbers that were attached to x, so I did that, and my potential answer was 7. But then when I checked my work and I substituted them in, I started getting that I didn't have the same answer. At the end, I got 21, and that does not equal 9. So that's why my final answer here was no solution. Please reach out if you have any questions.